Hello, we are Team Amigos. My name is Anirudh. My teammates are Manish, Anish, and Monish. The name of our project is Real Time Landmine Detection using HPC. Problem statement: we need real time detection of unexploded landmines with GPR signals using HPC.
And coming to objectives, the main motive of the HPC in the project is to reduce time of the model. And the resource code is very resource consuming, and our aim to execute the code is in both series and parallel and reduce extensive resource dependency. As Sir has suggested to implement ensemble learning, so we have trained one more CNN model on the data to make observation on both results. And coming to methods, we used autoencoders as primary model to implement it both series and parallel. The problem we have faced in this model is memory occupied is full and GPU is not used at full. So we made memory constant and used GPU at full by multi-threading. And we have trained CNN to use it along with the parallel autoencoder to make two different models run parallelly at the same time, which is ensemble learning. Now let's take a look at the demo.
Our project is an implementation from the research paper and its implementation, landmine detection using autoencoders on multipolarization GPR volumetric data. As per our objective, we have four implementations. One is the serial implementation, two is the parallel implementation, three is the training of the CNN model, and four, a prediction model with both CNN and autoencoders in parallel multi-threading. First of all, looking at the serial implementation, we have initialized all our GPUs and the process runs on our GPU. We have a window size of 64 cross 64 pixels. We have pre-processed the data to remove anomalies and missing data, and we are using a patch extractor to extract windows of sizes 64 cross 64 to make our predictions. As seen, the serial implementation has a batch size of 6 and is being executed without any multi-threading, just in a for loop. As you can see, the results, the accuracy of 96%, and the time taken is 232 seconds. Moving on to the parallel implementation, looking at the serial implementation, we made some conclusions on the memory utilization. As it was using extensive memory and bare minimal computation, we felt the need to efficiently implement it with multi-threading and task parallelism. As you can see, the data pre-processing in both the steps are the same, as well as the batch size and the samples. The difference comes when we are multi-threading the for loop to implement it in parallel way. Here we're using task parallelism and using multi-threading to achieve it. As you can see, the results of this are of 94% accuracy and the time taken is 110 seconds. Moving on, we wanted to test out our model with another model, basically test out two models in parallelism. So hence we trained a CNN model as with the data we had. The data dimensions are as seen. The model is a very simple model to avoid complexity. The model is as shown. It basically contains a convolution layer, a max pooling, and a dropout, and four such layers, and a dense and a flattened layer in the end. So this is the summary of the model. And moving on, we have saved this model and we have implemented it in our parallelism. Moving to our threading and multi-threading for parallelism, as you can see, we have implemented this in the for loop and I mean, in the multi-threading, and we are predicting results based on both the models. However, there's a key point to note that here we have reduced the increased the window size to 128, as we were having a memory outage, so we had to increase it to run it smoothly. And as you can see from the results, The time taken for this is 60 seconds, and at a trade-off of accuracy of 86%.
Now we'll see the results of our project. First serial implementation of autoencoders, it took around 232.4 seconds and with accuracy of 94%. And in parallel implementation of autoencoders, it took around 110.6 seconds and with the same accuracy 94%. These models use same batch size and same number of samples, and window size used by these two implementations is 64 into 64. Now in CNN plus autoencoder model, it took around 60.5 seconds and the accuracy is 86%. In this model, due to extensive memory usage, we increased the window size to 128 into 128. Thank you.